Okay. So, ER diagrams, we're not spending a long time in the course on this at all. We started it last class. We'll be continuing and finishing it this class, ER diagrams. ER diagrams are a way to construct a diagram that can enforce constraints on your data, on the way that you should create tables for your data. So in relational databases, which is what we're talking about in this course, only relational databases. There's other types of databases that we won't be getting into. But for relational databases, these are built on relations. A relation is, you can pretty much just think about it like a table. So when you're dealing with something like SQL, which is a relational database, you'll have different tables, and these tables will have relationships with one another, such that when you're querying, or when you have a query and you want some of your data back, it can reference different tables. Some of these tables might have a relationship with one another, and then you're returned sort of the union of each of these tables being merged together according to the constraints that you have. But before you start pumping your raw data into tables, you have something that's called a table schema, which is basically these are the tables that I want, and these are the attributes that the tables have. This is a primary key to the table. And we'll be getting deeper into these things when we start talking more about relational algebra and relations. Which, by the way, that's where the name relational algebra comes from. It's an algebra that you do on relations for relational databases, which is doing some combining of tables, basically. But if you have a bunch of unstructured data, and now you want to sort of take all of this data and maybe break it apart and put some parts into some tables, other parts into other tables, and stuff like that, what should your tables look like? And that is what an ER diagram is good for. It's a short kind of process you can go through so that you're comfortable with the way that you're going to be translating a bunch of unstructured data into tables. So an ER diagram, I'll repeat, is not a doodle. It's not a, well, this is an idea that I have in my mind, and just so you can follow what I'm saying more, I'm going to draw a couple diagrams. It's more formal than that. There's rules for what these things mean and how they're connected and these types of things. Okay. Again, if you look up ER diagrams online, which I'm happy for you to do, look at Wikipedia or, I don't know, CMU or whatever types of other resources exist out there. The vocabulary that we're using for ER diagrams is slightly more dated. And I'm fine with that because we're, number one, I'm sticking to, for a lot of things, this particular book. And this particular book, it's older, true, like in the 80s, I think it came out, late 80s, early 90s. 2003, I don't believe it. Thought it was older than that. Okay. Yeah, 2003, there you go. So in 2003, it's like 20 years old, this book, but relational databases are pretty static. at this point. It's not like other areas where the textbooks are changing a lot. Relational databases began around the 70s, and they're very well understood and kind of just fixed. So I like this book for other reasons, and so I'm just sticking to its convention for the ER diagrams because the book is older, it's free to find, it's easy to find, and who cares if people have another vocabulary for their ER diagrams. If you understand the way that ER diagrams work, it's a 10-minute task of figuring out when I draw this, you would draw that, and you can communicate with others easily. Okay. So let me get on to the vocabulary, as I'm calling it, for ER diagrams. Turn off that to make it more comfortable for everybody. All right. So this is. All right. So this is the vocabulary. We have entities that are rectangles. We have relationships, which are diamonds. We have attributes, which are ovals. And I'll just add one more, a keyed attribute, which is an oval with something underlined. So there's an example of a keyed attribute. There's an example of an attribute. There's an example of a relationship. And there's an example of an entity. And on the right here, that is an example of an ER diagram. Again, in your mind, think of these entities as something that will be translated and understood as a table. And when you're working in SQL, thinking of everything in tables is the right way of thinking about it. So although these diagrams are, pictorial, they have ovals and lines and stuff like this, there's a way to translate these into a table, and that's the focus of today's lecture. All right. Entities can only connect to other entities through some relationship. That is to say, you cannot connect two entities like this. If you have an entity A and B, and you want to connect them like this, no bueno. It's not good. Can't do it. Instead, these would have to go through some relationship to be connected. And that's the way to do it. That's the rule for ER diagrams. Again, they're not doodles. They have a purpose and rules. Aside from that, we have thin lines, which just mean that these things have a relationship. They're unconstrained. Entities are related. And that's all that it says. A thin line just says that these two entities are related somehow. Then you have a thin arrow, and this corresponds to, at most, 1. You have a thick line, and this corresponds to having at least 1. And then if you combine the two, a thick line and an arrow, then it's just the combination of these two. If you have something where you have at most one and at least one, then that means that you have exactly one. Let me move this over. These are called participation constraints. Okay, so the participation constraints is the thing that usually requires a little bit more thought. When you're coming up with an ER diagram, these parts up here tend to be the easy part. You know, like what are the entities? What entity has some relationship with other entities? What attributes do these entities have? And which one is the key that you are going to use? That tends to be the easier part. And then the part that requires a little bit more thought is how you're going to be making these connections. What are the constraints that you want between these entities? And that's it. Okay. We talked before about these types of relationships, having a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. Let me take a moment. Because one of the things that we'll be talking about more and more is set theory, which is fairly simple. Like, there's nothing complicated about it, but if it's the first time that you're seeing it, then it might require a little bit of your attention.
Professor?
Yep.
I have a question. Can you elaborate a little bit? How can the relationship itself have an attribute?
Sure. So, let me see really quick. Okay, I'll try to go through an example, I guess. Actually, no. I'll use this exact one up here. I'll copy it and then I'll kind of create the way that the table would work. So again, when you look at an ER diagram, understand that each of the entities, at least the entities and their attributes, are going to be translated into some table. And so the name of the table is what the key, or what the entity is. The entity is just the name of the table. And a table will have rows and columns. The columns are going to be the attributes. So in this case, the employee, this let me get rid of this first. So this entity that and its attributes that I've circled in red, that is going to translate into a table called employee. From the three attributes, we'll know that this table will have three columns, and the column names, or the type of information that's going to be going into that column, are the attributes. So here's the SSN attribute, here's the name attribute, and the lot attribute. In this table, there will be a lot of rows, John and lot 3, 2, 2, 2, 2, Susie and lot 5, whatever. This is going to be some concrete thing with entries in it, where each entry corresponds to some row. But the ER diagram doesn't concern itself with the specifics of these entries. It's just the format of the table, or the schema of the table. So that is going to be the case for all entities. All entities are going to be translated into their own table. Now, what about the relationship? And the relationship, it depends. It depends on the participation constraints. It could be the case. Yeah, well, here, let me copy this. So now I'll need to talk about it a little bit more. Let me copy that. Okay. So this is only part of the answer. The keep in mind, that was just me sort of wetting your beak about why we're doing all of this ER diagram stuff. Because it will translate into tables, and when we're working in relational databases, in particular SQL, everything is going to be tables or relations. Okay. Ooh, what to do? Why is this all white? What happened? Huh. Weird. Okay. Zoom in on this. All right. Cool. Okay. So let's be more concrete. This is an aside on set theory. And we'll talk more about set theory, maybe not this class, but next class for sure. Okay, but let's be a little bit more concrete here. So again, each of these, the entities, are going to go into some table. So this is going to turn into some table with 3 rows. The department is going to translate into some table, again, with 3 rows. So I'll have the DID, which is going to be a primary key, the department name, the budget. This is going to have a social security number as the primary key, a name, and some lot. Okay, now what about the relationship? Where is that? Well, oftentimes this can be its own table. So the relation is also a table. And so we want to connect this table and this table somehow. We're saying that these 2 tables have some relationship with each other. And the way that we're going to capture that, in this case, is by creating another table called works in. So this will be the employee table. We'll have another table, works in, and a department table. And because we want the employee table and the department table to have some type of connection between them, but we're limited to working with tables, how do we have this relationship between tables using a table? So this would have a DID and sense. So now we would have the works in table, in this case, translate to, or the works in relationship would translate into this kind of table. So if employee, let me try to do this in a different color, I guess. Whatever. Let's say, what? Why does it do this sometimes? It doesn't let me choose a different color. Whatever. Name. John, Paul, and Peter. We're in lot 1, 3, and 1. So, and the department ID, I don't know. There's Department 1, there's Department 3, there's Department 5. This is, I don't know, accounting, HR, and I don't know, IT. And their budgets. I don't know. 10K. Nobody likes AR, HR, so they only get 20K, and IT gets screwed a little bit with 80K. Okay, great. So let's say that we have these, so far these two tables, employee and department. And what we want to say is that employees work in departments. So we want to take certain employees, like let's say John, this employee. Which department does he work in? Employees must work in a department. Departments should have employees. So here, John might be in HR, and he's been working there since, I don't know, 2012. And Peter, he's in IT, and he's a new guy. He's been there for like a year. And Paul is in accounting as well. And maybe Peter and John, or John and Paul were friends, and they got hired together. Whatever. Okay, so then that's it. Here would be the way that in SQL, right, or any relational database, you would end up with this. So you'd have three tables, one focused on employees, one focused on the relationship, and one focused on the departments. You can add a new department, no problem. Throw it in the department table. So the works in table here is doing the job of connecting these other two tables. So it takes a key from that represents an employee, which is unique. By the way, the keys here are unique. You can't have repeat keys. At least for where the way that SQL works and stuff, like you can't have repeated keys. All the keys have to be unique. So if you wanted to say that this employee works in this department, you create a new table that says that identifies the employee according to their unique identifier. You match that with a department, which is a unique identifier of the department ID. And then because this works in relationship also has its own attribute, when did they start working, you have another column for that. Another thing. Yeah, so we're mixing up a little bit ER diagrams and relations, but it's a good question, and this is actually where we're kind of going. This relation here is not quite complete because I have to say that this social security number corresponds to that social security number, right? So if I have, or could I have this, 3333, working in HR since 2011. This, in purple, I cannot have. Because this social security number in the works in, that's referencing the keys of another table. And if the key doesn't appear in the employee table, 3333 in particular, does not right now appear in the employee table, then having 3333 in the works in table is no good because it doesn't correspond to anything in the employee table. Similarly, the department ID, this attribute in the works in table has to exist somewhere in the department table. Otherwise, you get some type of error. Okay. And okay. Another thing is that every table has to have a key. Right now we don't have a key for the works in table. I want to ask some students about this. So if I call on you, don't worry about giving a wrong answer, because that's the point. Like, I haven't quite introduced things, but I want to get you guys thinking yourself without me just laying it all out with the way it is. We'll combine the two. Okay, keys now have to be unique. Okay, so this key, for example, if we have John appearing twice here, the same John, the social security number now appears 2 times. It appears here and here. So that is not allowed, okay? Because that social security number is already taken. Even if you're trying to input the same person, that it's taken. Like, you cannot have in the social security column of the employee table, you cannot have 2 identical social security numbers, even if it's the same person. So this is not allowed. It would also not be allowed, or still not be allowed, if this was, I don't know, Amy. It's already not allowed because there's a repeat in the social security column of the employee table where 2 social security numbers are the same. So error. Can't do it. Same thing on the DID. For the department ID in the department table. Okay. So that's something that wouldn't be allowed. So let me get rid of that. Okay. We'll talk more about this. But right now, look at the ER diagram. The way that the employee is connected to the relationship works in, and the way that works in is connected to department. And I'll remind you of this. Actually, take a minute and write this down somewhere, just to have it in front of you. The entity, the relationship, the attribute, and especially the participation constraints and what they mean. If you don't have that like written down in front of you, take a minute, find something, jot it down. Because it's not always going to be on my screen, but it'll make this lecture easier if students have that in front of them. So I'll give you like 30 seconds. Okay. So again, the whole reason for coming up with an ER diagram is to just make it, it's a formal thing. It's not a doodle, okay? It's a diagram that you can draw. And the reason for this diagram is to make your life easier when you're creating the schemas for these tables. How many tables do you need? And more importantly, or more mind occupying, is figuring out what's the key. You need to have a primary key. And the keys are important because that's what the data structure is going to be. When you have an index table, it's going to be based on a key, and that is the whole reason why we did, the background foundations. What are these data structures? How are they built? They are built based on keys, right? You need, if it's a B plus tree, you need some attribute such that, in this case, it would be something that has a natural order, so that you can, navigate down and get to this thing and return the record. Okay, now that stuff you can just sort of imagine it happening in the background. I want a B plus tree; it's going to be built for me automatically and whatever. But it will be up to you to decide which key is this B plus tree going to be using. And it's not difficult, but it's also not obvious. So ER diagrams help to mainly help you determine what the keys should be for these tables. Right now we have 3 tables. Each of these have their own keys. We haven't figured out what the keys are for the works in table. That's what we're going to be talking about now. But I've already given to you the employee. Its key is the social security number. The department table, its key is the department ID, which means each of those tables are going to have their own index files. These index files, maybe for the employee, it's a hash table that you use for the social security number. Because, I don't know, what's the ordering? I guess you could kind of have an ordering for social security numbers, but it's not exactly natural. I don't know when you'd want a range. Give me, all of the social security numbers that begin in 401. I don't know how often that type of thing would happen. So maybe you choose a hash table for the employee, but the department, you have an ordering, based on, I don't know, their importance in the company or something. Accounting is super important, so it gets the number 1. HR, you need employee, whatever it is. Okay. Now, you have the ER diagram vocabulary in front of you. And right now, this ER diagram has just an unconstrained relationship between employees and a department, and between a department and the employees. Because they're thin lines, that means that an employee can work in 0, 1, or more departments. It's unconstrained. So, and those are the only 3. It can either be 0, it can be 1, or it can be more than 1. In this case, it's unconstrained, so all of them are kosher. An employee can work in no department, an employee can work in exactly 1 department, or an employee can work in many departments. Okay? The employee has a thin line connecting it to this relationship, so all 3 of these are good. How about the department side? Also a thin line, which means a department could have no employees, a department could have exactly 1 employee, or a department could have many employees. So each of these, the department and the employees, all of these are okay. That all of these are okay is being captured in the works in table. That's the heavy lifting that this relationship table is doing. So it should be okay to have an employee not working in any department. It should be okay that a department has no employees. It should be okay that an employee works in one department, it should be okay that an employee works in many departments. It should be okay that a department has one employee. It should be okay that a department has many employees. So how would this work? What are the keys in the works in table? I guess that's my question. Yeah. Right now I haven't specified which of these three are the key. Let me get rid of this 3333 thing. Could you make a composite key? SSN combined with the SSN. I'm seeing also just the SSN. Okay, let's try that. So this is a word that is useful. It's called a composite key. So the employee table has one key, the social security number. The department has one key, that's the department ID. The works in table will also have one key, but this key is going to be two keys that are like glued together. That's called a composite key. And the way I'm going to show this is with two arrows. First of all, I'm going to underline each of them to show that that's a key. And then I'm going to draw an arrow to demonstrate that it's a composite key. Okay, so what is a composite key? A composite key is when you glue things together. Okay, let me do this. This is called a composite key. Okay, before I give stuff here, how about Miriam? Because you brought it up. I'd like you to just maybe give me an example of a few composite keys.
Sure. So like when you go to the pharmacy, they always ask for like your name and your birthday. Because like someone could have the same name as you, but it's very, very unlikely that they have this same birthday. So that's a composite key where they ask for both pieces of information. Also, when you're like checking if you're registered to vote, they would ask for your driver's license number, but then they also ask for your full name. So it's like they ask for multiple pieces of information to make sure it's completely unique to you.
Okay, so for this particular table, or for this particular like works in table, what are an example of some valid keys?
What do you mean valid keys?
Okay, let's see. For example, this. Is that a valid key where this is SSN and this is DID?
I think it would be valid because even though you said that an employee can work for multiple departments, that's not going to happen at once. So if you do a composite key, you'd have, if they work first, if they have Social Security 111, right? They'd only have Department 3 once. If they work for a different department, then it'd be 111 and then Department 1 for accounting if they worked in both. So that would make it unique even if they did work in multiple departments.
Perfect, yeah. So even though the SSN, even though there's a repeat here and in the social security number, that's okay because the combination of the social security number and the department ID are unique. So both of these are okay. Miriam, could you give me an example of an invalid key?
That would be like, in terms of using both Social Security and DID, an invalid key would be like, would it just be if you did the same thing twice? Like if you put John working for accounting, so 1111 and then 1111 again? I don't know why you'd do that, but.
Right, yep, yeah, very good. Yep, perfect. So this is an example of what would be an invalid key because now we have a repeat. Okay? And it's not a repeat of one, the social security number or the department ID. Those types of repeats are okay. But you cannot have both of them appearing twice. So here, this exact same entry of social security number and department ID cannot appear more than once. Okay, so this would be an invalid key. This, if you have 1111 repeated 2 times, that's not good. Now this, so let me do this. All right, so that's a bad one. Right now, this is capturing the fact that an employee can work in more than one department. In fact, let me just start. I'll start just filling out this here. And I'll put a green check if it's good, or a red X if it becomes no longer good. Okay, so we have 1, 1, 1, 1, 3, and since 2012, 1, 1, 1, 1, Department 1. Maybe he started double dipping in departments at some later point. Who cares? This 1, 1, 1, 1, 1. I don't know. Maybe it's like this. That would be no good. This is no good. This is okay. That's okay. So this captures the fact that an employee can work in many departments. Okay. Good. Let me get rid of this. No. I'll just continue the possible keys in this table and have a green check. Everything, like this entire table, everything with a green check can be maintained in the table. Anything with a red X would be an invalid entry and not allowable. So I'll just sort of cross it out to emphasize that. Okay. How about Jessica? Yeah, Jessica S. No Jessica S. All right. How about?
Oh, sorry, I'm here.
Oh, okay, great, perfect. Yeah. So, what would it look like if a department were to have more than one employee? How would we capture that?
So it could be, so in addition to like Department 3 having social security number of 1111, it could also have like Paul, so 2222 with the department number 3.
Mm-hmm.
Yeah. And then just like any.
Yeah, whatever. Okay. Good. So there's no problem. Sorry, not there. There's no problem here that this key appears twice, because the department ID by itself is not the key. This is a composite key. So it's the combination of the two. So this is okay. And this also captures the fact that now a department can have more than one employee. Okay, and actually, I will end it here. I think that's good. So this also captures the fact that the IT department has 0 employees. That's captured in this, because if you look at the works in, there's no entry for anybody working in the IT department. Also, Peter seemingly doesn't work in any department. According to the ER diagram, that's okay, because an employee can work in no department. That's captured by the non-existence of the social security number 4444 in the works in table. A department can have no employees, as is captured by the missing value 5 in the works in tables column DID. And yeah, this captures almost everything about what's okay with with an unconstrained relationship. Okay, so in general, when you have an unconstrained relationship, you have to have 3 tables. Or you have to have a table for each of the entities and a table for the relationship. Okay? let's talk about some other constraints. So this is when it's unconstrained. And by the way, maybe, I don't know, like take a screenshot or something of this, or have your own notes or something. In any case, here, if you're not taking your own notes or you don't have stuff, it'll make your life easier if you do. Okay, so that is the case when everything is unconstrained. Now I'm going to make a little tweak. Just that. Okay. So the employee can work in no department. It can work in one department. They can work in many departments. But now, a department has to have at least one employee. It is not the case that a department can have 0 employees. So, I'll keep this. I'll keep this. Ooh. Okay. Again, the entities tend to be pretty straightforward. Those are pretty easy. Each of these entities, that's going to be the name of a table, and all of the attributes are going to be the columns, and the question is how to deal with the relationship. That tends to be the trickier part, as well as how do you capture whatever the participation constraints are. So what do I do? Let me give you 2 minutes to think about it, okay? So same thing. Does this mean the department only has 1 employee? No. This means that the department has at least 1 employee. If this were a thick arrow, then that would mean that the department has exactly 1 employee. But right now, so this is unconstrained. This is unconstrained. A department can have 0, 1, or many. By adding an arrow, it's a thin arrow. This says that a department can have 1 or many employees, but not 0 employees. It has to have at least 1.
Professor, I think if you go up to, could you scroll up to the participant constraints?
I'm sorry, you're right. Okay, yeah, at most 1. Yes, you're right. This is at most 1. Yeah, at most 1. Okay, so sorry, 0 or 1 employees.
Okay, great, thank you.
Yeah, sorry. Thanks. Jeez, thanks for catching that. Yeah, so this means at most 1. So 0 employees is okay, 1 employee is okay, but it's a strange company. They can only have departments with more than 1 employee are not allowed. Okay, apologies. Thanks for catching that so soon. Okay, so let me give you again 2 minutes. So at 11:23 by my clock. Yeah, how would we do this? I'll tell you that there's more than one way. I'll say that much. But let me give you 2 minutes. Okay, that's been 2 minutes by my clock. So, any ideas? Are you still working or are you lost? Lost. Add DID to the employee table. Let's, oh, that was sent to me privately. Okay. Let me do that real quick, and I'll work through what that would look like. What happens if we add DID to this table? So an employee, at most one. Let's see. Does this work? Okay, let's see if this would work. So, at most one employee. So, here we could have, I don't know, 2, 2, 2, for example. So far, this doesn't break anything, right? Our unique key on the employee table is social security number. All of those are unique, no problem. But now the department ID appears more than once, and this has a department that has, sorry, there is no department 2. 3, 3, 3. This doesn't quite work because we're not breaking any rules insofar as the tables are concerned. The social security numbers are unique in the employee table. The department IDs are unique in the department table. But now we have that doesn't break anything. But that does not agree with our constraint that a department can have at most one employee. So this doesn't work. Okay, that's no good. Good attempt, but yeah. Change the constraint to at least one. Yeah, it doesn't work that way. You're given constraints, and then you have to meet them. Yeah, you can't just say, oh, let's go back and make different constraints. That's not what your boss will say is okay. They have these constraints. It's your job to make them work. I like that, though. If you make another table again for the relationship, can you make just the DID keyed attribute? All right, let's look at what that would be like, just to save a little bit of time. I'll copy this and see what that says. So, this suggestion is, and I'll get rid of that because that's not good anyway, says, okay, we will still have the works in table, okay? Except now the keys are going to change, right? Instead of having it be a composite key, we're just going to have one key here. And that key is going to be the department ID, okay? So before, above here, notice 1111, this entry and this entry, they could coexist. That was no problem. Because the combination of SSID and DID, that combination remains unique. Because although the department repeats itself, it's a different social security number. So that's okay when it's unconstrained. All right, so that is a valid entry, this fourth one here. That's okay when things are unconstrained because of the way that we've chosen the key. Here, though, if just the department ID is the key, so now it's not a composite key. So that's fine. That's fine. This is no good. Now, let me stick to the green arrows. That's okay, that's okay. Now, this entry becomes invalid because the department appears more than once. Here and here. And this is our one single key where everything in that column has to be unique. So yes, this works. This is one way of doing it. This is one correct answer. Can you have the same key for two tables? No. I mean, in this case, kind of. I mean, the department ID, I mean, it's a key in both the works in table and the department table, but they're not like shared keys. Doesn't exactly work like that. In fact, I can expand on that. There is kind of a way that you can do that, but here, the DID being keyed in worksin and the DID being keyed in the department table, those are not the same keys. These are two separate tables. They just happen to both share the name DID. In fact, there's nothing that says, I mean, here, I could rename this department if I wanted to. And that's and I could make this keyed, so let me get rid of that. Make it a little bit more clear. Yeah, I could do this as well. There's no reason why the column in the worksin table needs to share a name with a key, even though you could do this, you know. Any key that appears in the department column of the worksin table must appear as a key in the DID column of the department table. But the name of the key can be different. That's fine. So actually, I'll keep it like that just to emphasize that point. This is okay too. Okay, the keys don't have to have the same column name in different tables, even if they're referring to the same thing. I thought department and worksin have the same primary key in this example. Again, kind of. They have the same key in the sense that any number that appears in this column must also appear in that column. In that sense, they're the same, but I don't feel comfortable calling them the same. That is to say, you know, like this entry, this entry is no good. So this one here, this is no good because of this conflict. Okay, that's why that entry doesn't work. This entry is invalid because this 2 doesn't appear here. So each of these bottom 2 entries in the worksin table are both invalid. They're invalid entries, but for different reasons. One is invalid because within that same table, you have a key appearing 2 times, and that can't happen. Given that that's the only primary key, it's a repeat. So everything has to be unique. That's why the 2222 is not good. The 4444 is no good for a different reason, and that is that this entry doesn't appear here. And this arrow that I'm doing here on top, now in purple, that you also need to write in an ER diagram to show where what that key references in another table.
So to clarify, Professor, that purple arrow you have to show when you're drawing out the tables, right?
Yeah,
Okay.
when you're drawing out the table. When you're drawing out the table, yeah. Yeah, and that will be captured, like when we write SQL, it will be a very straightforward thing to take this diagram of a table, which, by the way, this is not I don't think it's a standard thing. ER diagrams are a standard thing. There's textbooks on them. There's this kind of thing. This table representation is not formal, to my knowledge. This is sort of my own in-between to go from ER diagrams into relations. But for my own thing, yes, you need to draw this, like this purple arrow, you would need to have that. And there's a reason for when in SQL, you can write out the table schema very easily if you follow that. It is meant to be a thick or a thin arrow. That's a thin arrow. So a thin arrow means that a department can have at most one employee, which means it's also okay for a department to have no employees. You'll notice that, as in the previous example, the IT department doesn't have any employees, and that's okay. As is here, like the department, the IT department is void of employees. There's none of them. This example captures that, and that's okay. Okay, so because we're kind of running out of time, let me just, all right, this is method one. Okay, method two. There's another way that you could do this, where you have your employee, you have your department, and move things around here. Okay. Ooh. Yeah. No. Okay. Here's method two. So because the works in table is using the department ID alone as a key, then you can expand the department table, because the department table already has the department ID solely as the key. So another thing that you could do is just expand the department table. And you would give this a social security number and a works in since. Okay? And so here, to copy the above, you could have there the accounting department has employee 1111, and he's been working there since 2015. 3 has an employee also 1111. He's been working there since 2012. And the IT department doesn't have anybody. So, I mean, it doesn't really matter what you put here. Null. Okay, so now this method 1 table and the method 2, both of these are realizing the exact same thing. They just look a little bit different. So in all cases, an entity is going to be built into its own table. In this case, we have two entities, the employee and the department. So no matter what, you're going to have at least those two tables. So dealing with the entities is pretty straightforward. It's the relationship where things get a little bit hairy. In this case, we have two choices for how to capture that relationship. One is by creating a separate table for the relationship and keying it correctly. The other way of doing it is to just have two tables, but then to have the department table, in this case, pulling double duty by representing both the departments and the relationship with the social security number. And I should also add this, that there would be an arrow here. Okay, so the department table still only has its one single key. And yeah, it's okay that the social security number repeats itself in the department table because there's no constraints on how many departments a single employee can work in. And yeah, so I'll keep these here. In fact, for these things, I might print off a PDF and put this on Canvas. Yeah, for these things. I want you guys to take your own notes and stuff, but for this kind of thing, I'm afraid that I'd rather have your attention than for this lecture than you being vigilant about note taking. I still encourage vigilant note taking. Okay, and work through a couple of examples yourself. That's the best thing to do. All right. So there is. Man. All right. Boy. Okay. There's a few more things we need to do here. Sorry we didn't finish ER diagrams. We'll definitely, absolutely finish it next time. We have a couple more examples to go through. But anyway, now you have a very good preview. We've spent a lot more time talking about the translation of an ER diagram in this class to tables. Generally, that's something that I would have held off a little bit longer on, but I'm pleased with it. I think it grounds where we're going a little bit better. So it won't look past the initial employee that fills the restriction. Okay, so sorry guys, yeah, it's 11:40. You can go ahead and sign off. I'm gonna stop the recording and I'll hang around for questions if you guys have them.